Hello guys, welcome back. This is the class 2 of Wavey method. We'll start from where we left last time. So last we discussed this 10th problem. Now we'll start. What are the significance of these quadratic equations in solving inequalities? To understand that, we'll just revise what are quadratic equations. All of you have done this in your 9th or 10th grade. We'll just revise it quickly and see what is the significance here. So what are quadratic equations? The equation of the form ax square plus bx plus c. D is the discriminant, b square minus 4ac. And how do you find the roots? Minus b plus minus root d by 2a. All of you know this thing. Now, there are three scenarios. First is when d is positive. Then we have two real roots. See what kind of questions we have here. For example, x square minus 5x plus 6 you want greater than 0. So we have a quadratic equation. We find roots. You know how to find roots? Roots will come out to be 2 and 3. So we can factorize this thing as x minus 2 into x minus 3. And this is greater than 0. So you can just use the wavy curve method. We'll get x belongs to minus infinity to 2 union 3 to infinity. Okay, and this we can also write as this way. We can say all real number except the numbers between 2 and 3, including 2 and 3, because 2 and 3 we do not have to take, so we'll exclude them. Okay, next case. When we have only one real root, discriminant is equal to 0. So with the help of example, say x square minus 4x plus 4 greater than 0. We'll find the discriminant here will come out to be 0. So when discriminant is 0, both the roots are equal, come out to be a complete square, perfect square. X minus 2 square greater than 0. You know, x minus 2 square is always positive except at 2. At 2 value will be 0. You want greater than 0, so we'll say x belongs to all real number except 2 because the value at 2 is 0. And we say r minus 2. And how do we write that? We discuss. We use minus sign to exclude. And how do we add a single element inside this curly braces, which we refer to as a set. Okay, the last case, which is very, very important. This is the one we have to discuss in detail. When we have no real root, discriminant is less than 0 basically. Now you have to remember when discriminant is less than 0, the value of the quadratic thing will be either always positive or always negative. How do we get these things? We'll discuss them in detail later when we do the chapter quadratic equations. That time we'll discuss everything in detail. For now, you just have to remember few points and use it directly. Okay, what are the points here? So when we have discriminant negative, that means no real root. Just you have to check the value of c, this c. If c is positive, the quadratic will always be positive. If c is negative, the quadratic will always be negative. See how I have expressed here, ax square plus bx plus c greater than 0 for all. This symbol here where we write v and cut it across, we read this as for all. So ax square plus bx plus c greater than 0 for all x belongs to real number. That means this value will always be true. Ax square plus bx plus c will be greater than 0 for all real values of x. And when c is less than 0, ax square plus bx plus c will be less than 0 for all values of x, for all real numbers. I hope it makes sense. Let us see what kind of questions that we have here. X square plus x plus 1, you have to find the values of x for which is greater than 0. Quadratic equation, we try to find roots. What are the roots? We have to find with the help of d. When you find d, it comes out to be negative. Negative means no real root. If it is no real root, that means third case. C is 1, which is positive, means the first case. What does first case says? The quadratic is always positive. So x square plus x plus 1 is greater than 0 for all real numbers. So you can say x belongs to R, or we can write this thing as x belongs to minus infinity to infinity, which is basically all real numbers. Same thing. Next, give it a try yourself, guys, for this one. X squared plus 4x plus 7 less than 0. You can pause or give it a try. Let's start discussion. So again, you want the values of x for which this is negative, and discriminant comes out to be negative. C is positive. That means this quadratic will always be positive. So there is no value of x for which it is negative. I hope it makes sense to all of you. Now, we have finished all the theory points of this topic, Wavey curve method. Now we just do applications. How do we use it to solve some miscellaneous problems? So first one we have is this. I'll just give you this to try. Now pause and give it a try. Then we'll start discussion. Let us start now. So we have to find the values of x for which x less than equal to minus 4 over x plus 2. If you remember, we have discussed you never cross multiply. When we know thing is positive, we can cross multiply. When we know it's negative, we can cross multiply and change the inequality. But when the thing is variable, it could be positive or negative, we do not cross multiply. What do? We take it to this side and then use the LCM. So x plus 4 over x plus 2 less than equal to 0. We take LCM here, you get x square plus 2x plus 4 over x plus 2 less than equal to 0. Now we have a quadratic, we try to find the roots so that we can factorize and use the Wavey curve. But when you try to find the root, the d comes out to be negative. So no real root, third case. And c is positive. That means the quadratic is always positive. Now remember, whenever you're solving an inequality problem and you come to know that something is always positive, you just ignore that thing. For us, this does not exist now because a positive number do not make any change in the signs. So just ignore this thing. So for us, we just have like x plus 2 in the denominator. This will be 0 at minus 2. So critical point, or you can say root of this denominator is minus 2. Just use Wavy curve on this thing. Plus minus. You want less than equal to 0. So answer will be just minus infinity to minus 2. And minus 2 will be open because it is the root of the denominator. Denominator should never be 0. I hope it is clear to all of you. Next problem. 5x plus 1 over x plus 1 square less than 1. Pause and give it a try. Let's start discussion now. See, first of all, if x plus 1 is in the denominator, so x can never be minus 1. Otherwise, denominator will be 0, which is not allowed. So keep this thing in mind that the final answer should not have minus 1. Now, we have told you to not cross multiply, but in this problem, we can cross multiply. Why? Because x plus 1 square is greater than 0 always. Whatever be the value of x, this thing will always be positive. So we can cross multiply for this problem. You can do it by bringing 1 to this side and LCM also, but that will be a bit lengthy. If you just cross multiply, it will save you time. So always look for the best possible approach. So 5x plus 1 less than x plus 1 whole square. Here we can use a plus b whole square formula, identity, which is a square plus b square plus 2ab. So you get x square plus 2x plus 1 or 5x plus 1 get cancelled out, you bring all to one side. With x square minus 3x greater than 0. So take x outside, you get x into x minus 3 greater than 0. When we have x outside, that means 0 is a root. Do not ignore this thing. This thing is also kind of a bracket for us. And this will be 0 when x is 0. So this root is 0, this root is 3. Put both the roots on number line. Use the Wavey curve, plus minus plus. You want greater than 0. So it will be less than 0, more than 3. So minus infinity to 0, union 3 to infinity. But. In the beginning, we have promised we will not put x equal to minus 1 because it will not satisfy the original equation. And minus 1 will come out here in minus infinity to 0. So we have to exclude it. So minus 1 in the set. I hope it is clear, guys. Next problem. Next problem is x greater than square root of x minus 1. Solve for x. You can pause and give it a try. Let's start discussion now. Now here, a few things we have to keep in mind, guys. When you have a square root problem, few things you need to know about square root. See, square root is a function. Again, I'll not use the term function, you get confused. The square root is something which only takes positive values and returns positive values. It can take 0 also, 0 or positive. So, whenever you have a square root problem, in the beginning only you have to make sure the thing inside that is greater than equal to 0. So x minus 1 has to be greater than equal to 0. So x has to be greater than equal to 1. Now, one more thing here. What values it can give you? So if I say what is square root of 9, many of you might say square root of 9 is plus minus 3. Remember, it is wrong. Square root of 9 is not plus minus 3. Square root of 9 is only 3. It might come as a shock to many of you because you have been using it all your life. But guys, you are wrong. Square root only takes positive value and only gives positive value, never gives negative value. You might be using it like this way. X square equal to 9. There you say x is equal to square root of 9. So x equal to plus minus 3. X square is equal to 9. Then x is plus minus is correct. But the second step is not correct. The correct thing is when x square is 9, x is plus minus root 9. Root 9 is 3 only. But when x square is 9, x will be plus minus root 9. We'll discuss this thing in more detail in the next topic, modulus function. So after this wavy curve, next will be modulus function. That time I'll discuss this thing again in detail. For now, you remember square root only takes positive values and only gives positive value along with 0. So x minus 1 greater than equal to 0. So x is greater than equal to 1. Next. So when we have a square root problem, to solve it, we'll have to square. But there also we have some conditions. We should square only if both sides are positive or both are negative. What do I mean by that? See, if I say 4 is more than 1, you square both sides, you get 16, 1, which is still true. I say minus 4 is less than minus 1, then we square, you get 16, we get 1. Now equality will change. So both sides are positive, you square, it is same. Both sides are negative, you square, it will change. This is sure. But what happens if one side is positive, one side is negative? See, 4 more than minus 1. You square, you get 16, you get 1. So it is same. Now, 1 more than minus 4. Square, you get 1, you get 16. Now it will change. So can I say it varies from case to case? We cannot generalize anything. So when we have one side positive, one side negative, we cannot generalize. So do not square that time. You square only if both sides are positive or both sides are negative. In this particular case, we already have made sure x greater than equal to 1. So left side will be positive. Right side I told you square root only gives positive values. So both sides are positive. We can square. And I'll just change the color of this thing. So on squaring, get x square greater than x minus 1. Bring everything to one side, get x square minus x plus 1 greater than 0. Now for this quadratic, when you find d, it is negative, so no real root. C is equal to 1, which is positive. That means this is always positive. That means all the values of x are allowed here. You can put anything, it will always satisfy. Only condition we have on x is from the beginning. That is x should be greater than or equal to 1. So final answer will be x belongs to close 1 to infinity. You can check that any value we put greater than or equal to 1 will satisfy, and nothing less than 1 will satisfy. I hope it is clear, guys. Next problem. Next we have x square minus 2x plus 4 into x square minus 8x plus 12 less than 0. Solve it. Let us start discussion now. So we have two quadratics. First quadratic, discriminant is negative, C is 4 positive, so this quadratic is always positive. And like I told you, just ignore this thing, just deny its existence. Second quadratic, roots will be 2 and 6, so we have just two roots, 2 and 6. Plot them on number line, use Wavey curve, plus minus plus, you want negative. So answer will be just x belongs to 2 to 6. I hope it is clear. Next problem. 2x minus x square minus 3 into x square minus 4 greater than or equal to 0. Take a pause, try it yourself. Let's start discussion. See this first quadratic, we have minus x square. We are more used to when the x square term is positive. So I'll take negative common outside and then multiply both sides with minus 1, which will change the inequality. So it was greater than or equal to 0. Now it will become less than or equal to 0. So you get x square minus 2x plus 3 into x square minus 4 less than or equal to 0. Now for this quadratic, d is negative, c is positive, so it's always positive, ignore. For this quadratic, roots are plus minus 2. So just plot plus minus 2, positive, negative, positive. You want less than or equal to 0, so x belongs to close minus 2 to close to, because we can have equal to 0 also. I hope it is clear. Next problem. 2 power x minus 1, x minus 2, x minus 3 greater than 0. In this problem, we have a new kind of thing here, 2 power x. So give it a try. Let's discuss. Let's start discussion. See, the concept will be same. We have to find the value of x for which this bracket is 0. That will be counted as a root. So 2 power x minus 1 will be 0 when 2 power x is equal to 1. And 2 power x will be 1 when x is 0. So root here is 0. Here is 2. Here is 3. Plot them on number line, plus minus plus minus. You want greater than 0. So 0 to 2, 3 to infinity. So open 0 to open 2, union 3 to infinity. I hope it makes sense. Next problem. We have x into 2 power x minus 1, x plus 1, x minus 1 greater than or equal to 0. Give it a pause and try yourself. Let us start discussion. See this root, we discuss 0. This root, 0. This root, minus 1. This root, plus 1. So there are four roots, 0, 0, minus 1, but 0 comes even number of times. And I told you, the root which is even number of times, we ignore that for number line. So we ignore 0 and plot only minus 1 and 1, so plus minus plus. But we have to remind ourselves that the value at 0 is 0. So between -1 and 1, value is negative, except at 0, where value will be 0. You want greater than equal to 0, so it will be before -1 or after 1. So minus infinity to -1 closed, union close 1 to infinity, union 0, because value at 0 also is 0. You want greater than equal to 0, no? I hope it is clear. Okay, guys. So that is from in this discussion. Now I'll give you some question to try on your own, kind of an assignment. So there are some 7 to 8 problems. You will try them on your own. And the next class, I'll give you the key and the solutions. We'll discuss all the problems there, and I'll give you the key also. So right now, I'll just show you the problems. You can write it down or take a screenshot or whatever you want to. Or you can just pause this video and do them straight away. I'll just show you. Question number 8 is x greater than square root 1 minus x. Question number 9 is x cube plus x square plus x plus 1 less than 0. Question number 10 is x square minus 6x plus 3 into x square minus 6x minus 2 less than equal to 50. This is a very interesting problem. My favorite. 11th, x square minus 3x plus 2 into x cube plus 1 by x square minus 7x plus 12 into x cube plus 8 greater than 0. 12th, 2x by 2x square plus 5x plus 2 greater than 1 by x plus 1. 13th, x minus 2 power 1000, x plus 1 power 253, 2x minus 1 power 971, x plus 8 power 4 by x power 500, x minus 3 power 75, x plus 2 power 93 greater than equal to 0. 14th one, x square minus x minus 1 into x square minus x minus 7 less than minus 5. 15th one, square root of x, square root of 2 plus x minus x square greater than x minus 4. Okay, guys, you can try them in the next class. The class 3 I'll upload. I'll give you the key of all these problems and the solutions. Bye, guys.